Scientific notation. Scientific notation sounds like it should probably be in science, right? Well, guess what? It is. It is in science and math. But basically, what is it? It is a compact way of writing a very large or a very small number. It's written as the product, multiply, of a factor and the power of 10. We've talked a little bit about exponents, but the exponent is very important in scientific notation because it tells you exactly where to move the decimal. For example, if our scientific notation number is 5.34 times 10 to the fourth power, this exponent means move it 4 spaces to the right. 4 spaces because that's the number of your exponent, right because it's positive. So if I take this decimal and I move it 4 spaces to the right, this is the number I end up with, 53400. I had to fill in the empty spaces with zeros. 7.42 times 10 to the fifth power means move it 5 spaces to the right. So this decimal is going to go 5 spaces, 1, 2, and then I'd have to fill in those other 3 spaces with zeros. So that's why you see that I have 3 zeros at the end of my number. 3.27 times 10 to the negative 3. That means 3 spaces to the left because it's negative. Well, here's my decimal. I move it 3 spaces. 1 space is taken up by that 3, and then 2 extra spaces have to be filled in with zeros. So here's my 2 zeros in front of the number. This 0 decimal in front, this is just a placeholder. It has no value. 8.7 times 10 to the negative 4 means move my decimal 4 spaces to the left. So here's my decimal. I move it 4 spaces. That first space is taken up by the 8, and then I have to keep going 3 additional spaces. That's why you see 3 zeros in front of the 8. Okay? So that is how to take a number out of scientific notation and put it in standard form. But what about the reverse? What about taking a number in standard form and putting it into scientific notation? So the first thing we have to look at is, where does our decimal go? In all of these examples, your decimal goes behind your first number that's not a 0. So in this number, what is my first number that's not a 0? 3. So my decimal needs to go here after the 3. Well, where is it now? It's always at your end of the number when it's a whole number. Count how many spaces that is. 1, 2, 3, 4, 5, 6. 6 becomes your exponent, and it is a positive because your number was greater than 1. So your scientific notation number is 3.725 times 10 to the 6. If you're ever confused about how to put it into scientific notation, once you do it, solve it this way and see if you ended up back with the same number that you started with. Okay, so here's some more examples. This is the number that we started off with, decimal 0.00316. Well, my decimal needs to go in between the 3 and the 1, so how many spaces is that? 1, 2, 3, 4. So my exponent is 4, but it's negative because the number that I started off with was less than 1. Decimal 0.0876. My decimal needs to go in between the 8 and the 7. So to get it there, I have to move it 3 spaces. That's why my exponent is a 3, and it's negative because my number started off less than 1. 52,300,000. My decimal goes in between the 5 and the 2. How many spaces is that? 1, 2, 3, 4, 5, 6, 7. My exponent is a 7. It's positive 7 because my number was greater than 1. And the same thing, 6,700,000. I had to move it 6 spaces to get it there. And my exponent is positive because my number was greater than 1. When writing a number in scientific notation, the exponent is the key. If the number is greater than 1, the exponent is positive. Less than 1 is negative. The exponent tells you where to move the decimal. So now that we know how, let's just do a few examples. Right here, I've got some numbers that are in scientific notation. I'm going to take them out of scientific notation. 8.73 times 10 to the negative 4. That means 4 spaces to the left. And if I move this decimal 4 spaces to the left, one of those spaces is going to be taken up with the 8, which means I have 3 spaces that I have to fill in with zeros. 1, 2, 3, 8, 7, 3. Here we go. 6 spaces to the right. So I'm going to have 1, 2, 3 spaces already taken up with numbers. So I'll have to fill in those last 3 spaces with zeros. So now I'm going to go back in and add my commas where they go. 7.8 times 10 to the 3, move it 3 spaces to the left. One of those spaces will be taken up by that 7. 3.16 times 10 to the third, that means 3 spaces right, 1, 2, and then that third space will be filled in with a 0. 6.5 times 10 to the negative 6. One space will be taken up by that 6, and then I need 5 more zeros. 1, 2, 3, 4, 5, 6, 5. So you do not ever just look at the exponent and that's how many zeros it gets. Some of those, that's how many spaces you move it. And some of those spaces get taken up by numbers that are already there. Okay, here we go. I've got 0.0072. I need to know how to put that into scientific notation. My decimal goes here. So it's 7.2 times 10 to the, this is 1, 2, 3. 1, 2, 3 spaces. But it's negative because my number started off less than 1. 329,700. My decimal needs to go here. It's at the end of the number, so 1, 2, 3, 4, 5. 3.297 times 10 to the 5th power. It's positive because this number started out greater than 1. 9.01. My first number that's not a 0 is 9. 1, 2, 3, 4, 5. 9.01 times 10 to the negative 5. My number started off less than 1. 4 million. 1, 2, 3, 4, 5, 6. So it is 4 times 10 to the 6th power. If it's just one number, you don't even need that 4.0 because you drop any unnecessary zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. 2.605 times 10 to the 9. And that is scientific notation.